I think we're ready to get started. I'm Dave Lago. I'm from the Hosting and Compute Center. I have with me Alex McFarland, wherever he is. All right, so I'm standing between you and happy hour, so I'm going to try to make this quick, although I appreciate the turnout that we got here. So we live in a era of TikTok, so I have between 21 and 34 seconds to make my point here before everybody checks out. So let me try to take advantage of that. The theme of the conference is innovation, right? And key to innovating is the ability to succeed or fail quickly. And the emphasis is really on the quickly part, right? So to do that, we need the tools of innovation, and we need them readily available. We don't want to have all the barriers to entry that the government's really good at creating for itself, right? So we have all these acquisition problems, we have integration, we've got accreditation, we've got maintenance, right? We need these tools readily available, and we need them at a price point that customers can afford, and that's really, the center of Vulcan. All right, a little bit about, next slide. There we go, that slide. All right, a little bit about the Hosting and Compute Center. If you haven't heard of us, we're relatively new. We want to be the best value trusted provider, whether you're talking about the commercial cloud, private cloud, hybrid cloud, space cloud. I'm just checking. Space cloud's not a thing. I'm just making sure everyone's listening. But you get the idea, all right? That's the play. And a little bit about our portfolio. Some of these things you've probably heard of, some of them you haven't. So the first one is JWCC, the Joint Warfighting Cloud Capability. Right? This is the most famous cloud contract ever. Right? Your grandma has probably heard of it under its previous name, JEDI. I think we're all familiar with what that is. All right? So this is the ability to buy commercial cloud from the big cloud providers, AWS, Azure, Google, and Oracle. Okay? This is a $9 billion contract. Okay? I think we're all familiar with it. I think what doesn't come up a lot is the problem that it solves. Okay, so if I want to do a cloud lab with my daughter and expose my daughter to the cloud, I can take out my credit card and I can get running in any of the cloud providers probably in under 15 minutes. All right? So what does that look like for DoD? We know it's not like that. Okay, the reality is, and I can tell you from living it, is that it takes a year. All right, so you want to do a pilot, you want to try out the cloud, you have to wait a year to get a cloud contract to get in there. So what this solves is it breaks down that barrier and gets it down to weeks, right? So that's a considerable accelerator to cloud adoption. The next one is Stratus. So Stratus is a private cloud. It's self-provisioned. It's VMware based, right? So you can go in there and launch your VMs. The beauty of it is that you gain all the DISA networking that's built in there, right? It's already on the DoD. Right, they've already figured out all that network part, which is pretty key to what we do. The next one is DoD Cloud IAC. This one is very near and dear to my heart because I helped start it and I ran it for 2.5 years. So this is a cloud adoption accelerator, and these are templates that build out secure cloud environments in 4 hours instead of seven months of engineering. So every time we do this for a customer, we save them about $500,000 in engineering labor, and we've done it for 36 DoD customers. Okay, big customers, big platforms. We don't talk about the customers publicly, really, but big platforms, little pilots, everything in between. So highly successful thing. What's really worked is it comes with an ATO from DISA RME. So somebody's already gone through and made sure that it's secure and validated that it's secure. And then the documentation. Each one of the baselines comes with an admin guide, a security guide, a deployment guide. You can even launch these things on your own, or we can help you build out your environment, do it in a 4-hour session, and you'll be on your way. It's a decentralized cloud play, if you will. These are made possible by CRADAs, collaborative research and development agreements with the cloud providers. Okay, so cloud providers are not making money if it's taking people years to get to the cloud, right? So we have the same goal in mind here at the Hack. We want to get everybody up and running in the cloud so that we can innovate, right? The theme of the conference here. The best part is this is free, right? So this is a free service. We're just trying to help as many folks as we can. All right, the last one here is containers as a service, or CAS. They just briefed, if you heard them a little while ago. Okay, this is a container play. So same kind of idea as Stratus, which is it's a VM play. This is under the covers. It's Red Hat OpenShift, and lets you get onto the Doden rapidly. They figured out all the networking part. You don't have to do the container platform SRG. Right, you can just worry about your containers. So this is kind of a way to skip forward if you want to adopt containers. All right, okay, DevSecOps. So I get deja vu when I talk about DevSecOps because this used to be my job. All right, 7 years ago, maybe it was 7.5 years ago, I was responsible for my Navy command. I was a civilian for introducing this new thing, DevSecOps and Agile, right? And we were actually pretty successful. We were the first military organization to adopt DI2E. If you're not familiar with DI2E, it's a collection of tools. We've modeled a lot of what we're doing here, after DI2E, that really did a lot to advance DevSecOps, as we know it today in the department. And I remember then, learning about, I was a traditional systems engineering guy, learning about DevOps and Agile, and thinking, wow, this is amazing. This is really going to take off in DoD. This is going to spread like wildfire. Anybody feel like it spread like wildfire? Maybe like kitchen fire or like a solo stove. But I wouldn't say wildfire, okay? We're doing with DevSecOps what we do with a lot of things, which is the centers of excellence. Okay, we have some centers of excellence that do a really good job. But as a whole, it's probably not where it should be, right? And there's a lot of reasons for that, and we're going to talk more about that. You hear me talk, and you're like, this Lago guy hates waterfall. Okay? It's not true. I have a master's degree in systems engineering. I loved it. I did it for 15 years. All right, but systems engineering, a traditional waterfall has its place. And for me, that's things like buildings. You're going to build a building. Right, it should probably be a waterfall project. You're going to build a satellite platform, probably a waterfall project. Right, the network. Okay, we're DISA. We own the Doden. Big deal for us. Probably a waterfall project. Right, you're going to build a plane, waterfall. Car, waterfall. Oh wait, but let's talk about that because that space is kind of shrinking, more and more every day. All right, so I'm a federal employee. I drive a Honda Accord. Kind of a no-frills thing, but if you have a Tesla, okay, part of the experience of having a Tesla is you have that big screen right in front, and what's running on there? Software that is continually updated. Right, so you can bet that the car part, the platform, is a waterfall project, but the software, for sure, is done in an agile way. So the space for waterfall, traditional waterfall, is shrinking. Although I think in DoD we haven't come to terms fully with it. I think part of the problem is the availability of tools. Okay, everybody has Microsoft Project. Everybody has a spreadsheet. Right, so everybody can pull together their integrated master schedule, right, and go forth. Does everybody have Jira? Does everybody have GitLab? Not so sure about that, right? So that's really what Vulcan is about. All right. So talking more about DevSecOps, I'm ranting a little bit, but I'll keep going. So I'll give you my interpretation if we can go back just one. So Dave's interpretation of DevOps, it's really about doing things more iteratively. Okay, instead of writing code for 6 weeks and then finding out if it's going to compile, right, we're going to do nightly builds instead. Right? Agile. This is the ability to course correct. Okay, this is where we get in a lot of trouble in DISA, or DoD rather, as a whole. Okay, so what is the bread and butter contract in the federal government? It's the multi-year fixed price contract. Okay, so that is very problematic, in a landscape that's constantly evolving, right? I'll give you a couple practical examples here. Let's say I was in charge of an AI/ML portfolio. And they said, okay, Lago, we're going to get you your contract with multiple option years. It's going to be fixed price. Write down all of your requirements 3 years in advance. Okay, so write them all down. All right, so then 2 years into it, something called ChatGTP comes along. Right? How many phone calls am I going to get about ChatGTP, and when am I going to offer ChatGTP and a service like that? And my hands are tied, right? Because I am tied to this very, fixed price contract, multi-year approach, right? What we really need to do is be more agile, and also with contracts. And I think all of DoD, is having a hard time with this, right? So we want to put product managers, instead of being in the back seat of this contract that's going on for multi-years, put them in the front seat, right? We want to give them the ability to pivot. Okay, if something comes up, ChatGTP, we can do a ChatGTP. Another prime example would be in this AI/ML portfolio. I remember I managed a platform and one of the big cloud providers, and a customer was standing up an AI/ML capability. They were integrating TensorFlow, right, and NoSQL database and all these things. Right, and then we were kind of looking, and we're seeing that SageMaker is going to come out in a month. Right, so if you're doing a fixed price contract, how do you cost that out? Okay, so we're talking about, so if we do it the old-fashioned way, you're talking about months of engineering and a big effort. If you do it, take advantage of SageMaker, right? Use something like DoD Cloud IAC and a small team. You can stand that up in 2 weeks. Okay, so how do you price those two things out, right? So those are the big challenges. So what we really need to get to is being more agile, right? Doing things like more IDIQs, shorter duration. It can be fixed price, but it's got to be shorter duration, cost plus, things like that. So I think that there's space here for the government, to approve on agile. All right, so continuous integration, that part of it, I think that we've cracked that nut in the Department of Defense. Right? I think everyone knows Jenkins. They got good at that, especially the contractors. Right, Git, which you can talk about here too. The seat continuous deployment part. I know the DoD CIO folks were here earlier, and they really do a great job describing it. I think Rob Vietmeyer was here as well, but he talks about that very few organizations are doing actual continuous deployment where you're deploying into production. Right, the reality is probably a lot less than 10%. Right, so we, even though we've been talking about this DevSecOps thing and CI/CD for 7.5 years now, very few in the department are going all the way with it. And then SecOps, so moving security to the left. I think that is part of what's going on too, and it's still in its infancy, especially on the compliance side. Right, as we move from kind of paper-driven compliance to more data-driven compliance, right? But I think it is happening, and I think it's an exciting time, to be in that space. All right, now next slide. All right. Okay. So what is Vulcan? Vulcan is a collection of DevSecOps tools and agile tools offered as SaaS. All right. You can think of this as a portfolio. Okay. So we are going to expand the portfolio over time, and I'm going to talk more about that. But initially, you've got Jira, right, which is an agile planning tool. You go in, you put your user stories, right? You're doing your sprint planning meetings. You're assigning story points to tasks and tracking velocity and all those things. If you haven't experienced that, you really, especially on the government side, you need to get exposed to that because it's a much different approach. All right, then Confluence, which is a documentation wiki. And then the last one is GitLab Ultimate. So GitLab Ultimate allows you to create DevSecOps pipelines. One kind of point here that's interesting, we'd started the project, we were looking at GitLab Premium because we were so focused on price. And somebody from this leadership, and rightly so, pointed out that, hey, that's really, you're a DevOps platform, you're not a DevSecOps platform, that you need all the security capabilities built there as well. And again, this is not an exhaustive list. This is the initial one. Something that's what Vulcan is. What Vulcan's not is a platform. Okay, so if you're familiar with all the great DevSecOps platforms that we have in the Department of Defense, there's a lot of them. They are great. They have their space. This is a different approach. This is a SaaS, pure SaaS play, right? And we're targeting best value. All right. So web.git.mil. Let me talk a little bit about that. So web.git.mil is something that we stood up for global directory. Okay, it's self-service, it's CAC authenticated, and we used it just internally. And then we have partners and friends in the government, and they said, hey, we need a repo. We said, we got a repo, and it grew. Okay, and then it grew and it grew and it grew, and literally didn't include the chart, but if I showed you the customers, it's on a curve like this, right? So this has been around for a year and a half. There are 3,300 users as of last week that I checked, and pretty impressive. Like, obviously there is demand signal, for a repo like that, as we're seeing. These customers are all across DoD, Navy, Marine Corps, Army, Air Force, combatant commands, you name it. So that has been cool to see. That is something that we offer for free, but as all these things go, there's pros and cons to everything, right? There's less feature sets, with the freebie, the reality of economics, right, versus what we're offering in Vulcan. All right, so more about the best value play here. So this is not a big program of record. Okay, the reason we're keeping costs down is that we started with really a two pizza team. Right, if you're familiar with that concept from AWS. So this platform itself was the tooling. Let me not say platform because that's the wrong word. This environment was built by Alex and like one other person, right? Which is pretty impressive, right? To build an enterprise capability like that with a couple of people. And so how did he do that? Okay, so he used DoD Cloud IAC, which I talked about before. Okay, so he built out, the environments, the virtual networking environments, all of that, the connectivity to GFUD, which is Global Directory, all these things. And then he took Air Force Platform One Big Bang. Okay, that's another organization that needs a lot of kudos in the DevSecOps space because they've done a great job and they've done a lot to advance DoD in that space. If you're not familiar with what Big Bang is and what Iron Bank is, it's cool, and I think it's changing a lot of views in the Department of Defense, which is really important. And so we are now going through the Defense Working Capital Fund process. I don't want to. I'll quote you a rough price just to give you order of magnitude. But it's not the final price, and I guess you guys can tar me later. But the plan is for Jira and Confluence to be around $130 per seat per month. And then for GitLab Ultimate to be $260 per seat per month. No minimum buy, so we're just trying to get these tools out, to the masses. A couple more points here, and then I'm going to pass it over to Alex. So another kind of cool thing about us not being a DevSecOps platform, upside, if you will, on that, is that we recognize that customers are really in a pretty broad spectrum, all right? If you think on this side, bare metal, server builds, right? Somewhere in here, there's virtual machines. We got containers, we got PaaS, we got SaaS, right? There's really that spectrum, and very few customers, in fact, no customers are in just one of those. Okay, so there's no organization that's only containers. There's no organization that's only VMs. You're a mix of that. Okay, and so the way we do that is for the BYOB, this is BYOR. This is bring your own runner, right? So you build a runner, the runner lives behind your firewall, and it connects up to Vulcan. So again, this is another decentralized cloud computing model. All right, I beat it to death. I think I got it all. Alex.
Thank you, Dave. As I get started here, it's probably worth talking about, Dave talked about what DevSecOps is, but it's probably worth talking about necessary versus sufficient conditions, right? So I would argue that in this day and age, especially with a remote workforce, that some project planning tools like those in Jira and Confluence and those that are built into GitLab are necessary. I would argue that CI/CD pipeline stuff is necessary, but it's not sufficient, right? You can buy these tools, but doesn't mean you're doing DevSecOps just because you're giving your money to us, right? All because I give you a hammer doesn't make you a carpenter. This requires organizational change and collaboration, and there's a lot of hard work that goes into that. And really, when we think about what makes the best DevSecOps tool, It's going to be anything that drives the collaboration of people and processes, which is probably arguably the biggest problem that we have in DoD in general when we're trying to work together. So I would keep that in mind as we start to roll through things. The other thing here, and actually, can you next slide, please, is people, when we talk about why we want to do this, why is this good? What is the benefit of it? People always talk about speed. They want things faster. But I think that oftentimes the point is missed that speed is a byproduct of other aspects of this, right? Really, what we're talking about here, this is a quality play. The quality improves the safety of the system, and the safety of the system is what allows you to go so much faster. So what does that mean and why? Well, let's take a step back and define what the CI/CD means. So CI stands for continuous integration. So what we're talking about, we have version control, which is a way of managing text files. So you make a change to a text file, you can see who made the change at what time, and it also allows other people to make changes to the same environment and then merge those changes down the line. Now, what happened is over time, maybe Dave's making changes and he works on that for a month, and then I work on it for a month, but our stuff is so radically different at this point. Now we have a major issue trying to bring those changes together in a cohesive process. Again, like the collaboration of people and processes, right? We were working separately and we were coordinating. So this practice called continuous integration came along, where the idea is we're merging our code together very, very frequently. We're doing it regularly. And by minimizing the amount of time that we spend working in isolation and bring that stuff together, we get faster feedback from each other, but we also decrease the odds that we're going to have problems down the line. CD can mean continuous delivery, so you've produced some sort of artifact from your software and you're publishing it, or it can mean continuous deployment. Deployment meaning it's actually running in production. Now, to think about this in a term of something that we use all the time, let's think about like an app on your phone, right? So some developers somewhere, they wrote this app, they did their testing, they got it running, and they deployed this to an app store. Well, that's the continuous delivery. That's up there. It's deployed when it's on your phone, and when it's updating silently in the background, now it's continuous delivery. Now, we don't have this maturity in a lot of our DoD applications, right? And you kind of ask, why? Well, I think we tend to be afraid of change. Because change is scary, right? Change breaks things. We don't want to do it that often. We don't like to do things that hurt. So developers, for a while now, they came up with these best practices of CI/CD. So we're going to make smaller changes, and we're going to make them more often. And we want to deploy more often to make it safer. That seems kind of backwards, right? Deploying more often to make something safer. Well, think about the blast radius. If I collect 3 months of work and I push that out at one time, that is a giant change for that system. If something goes wrong, it's much harder to identify the thing that broke the system in the first place, and there's a lot more risk there. Even in terms of maybe what I did just doesn't, in terms of lost value, right? Like we lost time. Maybe what I did ends up being the wrong thing when we get feedback on it. So it's better to deliver smaller changes more often. This is a tenet of Agile, but it has very practical impacts. And Dave was talking about automotive shops doing waterfall, but they've also embraced lean practices where they're learning and adapting and fixing their lines the whole time too. So they're constantly improving. Another key process of this is there's different types of testing that are part of this pipeline. So you have integration tests. So an integration test, you'll hear this as part of something called test-driven development a lot of times. So the idea is you have a small piece of the code. So maybe you have a small piece of code that's filtering some characters to avoid like a web security vulnerability like a SQL injection attack or whatever, right? And maybe it's filtering out these things. The integration test is just testing, when I feed those characters into this, does that little piece of code do the right thing? Now, that integration test does not tell you if that works well in the context of the larger system, if everything is running well together. And that's where we have functional testing. Sorry, that was unit testing on the last one. The integration testing now is when we're bringing everything together. And then in functional testing is sort of similar. So this is how things work when they're running together. I've seen a meme that illustrates this pretty well. And there was 2 windows in a corner of a building, right? But the knob to open the windows were right together. So the windows individually, they work perfect. The latch works, you can pull it, it would open. But next to another window, it bumps in the latch on the other side, and you can't open either window. So that's perfect unit testing, but poor integration tests. Another practice that is key to all this is peer reviews. And this is where the GitLab Ultimate stuff becomes useful. You can do it in the free git.mil, but GitLab Ultimate also has enforced peer reviews with somebody at your level where you have to have like a 2 keys thing before a change moves forward. So what's interesting about peer reviews is, the idea is that they're sort of supposed to address a lot of the problems that a change control board does. Is this a good change and is it safe? And there's been a lot of academic research that shows that peer reviews are extremely effective in terms of detecting defects, making things better. And you know what? Change control boards really aren't. They mostly just slow us down. We're not getting away from that anytime soon. We have them, but I think that's the reality of it. So you look at this pipeline here, and this is a lot of times how we think about a DevSecOps platform, because we start to bring operations into the picture now. Because a big part of this is feedback loops. Feedback loops being, I am learning from what I am doing, and I'm getting that result back, so I know if what I did the right thing is good or not. And that's another advantage of the small changes, right? You get fat, you know if what you did was good or not because you're seeing if it's working. So you start out, you do your planning, maybe in Jira Confluence, maybe in the GitLab tools. You write your code locally. You probably have some sort of local testing. You check into GitLab, which is running under Vulcan, and you release it. So then you have your runtime environment. Now, in the context of Vulcan, to Dave's point earlier, you own your runtime environment. That's where we're different from somebody like Platform One that's running everything front to back. Now, that means there's more on you, but it gives you greater flexibility, and it means that we're addressing a broader range of environments. It's a little less opinionated. So we have lots of runtime environments to hack. JWCC to purchase cloud. You can run your workloads in Stratus. You can work it. Run them in containers as a service. And then in terms of monitoring, there's this CSSP that monitors your stuff. You should also be monitoring things other than just security, right? You should be monitoring how are people using the system, application performance metrics, are your users happy, and getting that feedback and then feeding it back into the development process. So this is where developers and operations have to work together. Now, what's interesting about these development practices is devs have had this for a long time, right? This has been the way software has been developed for quite some time. But as we start getting into infrastructure as code, operations teams can bring this to bear too. So typically infrastructure as code is a little different than your typical programming language insofar as it's a declarative language versus an imperative language. Well, what does that mean? So an imperative language takes all the sets of conditions, it's a full set of instructions on how I'm going to do something, right? Like I'm going to build the car, put it up on the jack, put the wheels on, paint it this, do this, and to get a car, right? A declarative language says, I want a red car with these kind of tires, and that's it. And the complexity is handled behind the scenes. The reason that is done with infrastructure as code is we just want to describe what our infrastructure looks like. We want to say, this is what I want, make it that way. Well, we do that in text files. So now we get to use a lot of these same sorts of tools that developers have been able to use at the same time. We get to do peer reviews in text, and we also have everything is audited and tracked and done all along the way. And then we get into continuous deployment. You make your environment look like that code. Now, when you talk about like a sort of a 3-tiered dev, test, prod environment, this gets really interesting too, because now your dev, test, and prod can be exactly the same because you didn't have a human involved, making changes, and there shouldn't be any configuration drift. Next slide, please. So now you have your infrastructure, your actual operating environment, right? Every change has been peer reviewed, every change is audited, you have a history of it, and you have small changes. So we start moving these changes through more quickly. We're not saving it for 3 months of changes. Things are less likely to break. We practice deploying. We get better at it. Well, so now a trendy part of this is GitOps. So GitOps is kind of handling an aspect of the continuous deployment side of continuous deployment, right? So the idea here, this is typically seen with Kubernetes because it's a little bit easier there, because usually when we're looking at infrastructure as code, we're describing the environment. Well, in Kubernetes, everything is an abstraction of an API. So all we have to do is say, hey, I want it to look this way, and it matches. Typically, it's done in YAML files. So how this works is you check these artifacts into a Git repository. There's an agent running on your cluster. Usually it's Argo CD or Flux, and it's watching the repository for changes to a specific branch. So all your change control and everything has happened upstream of that, right? It sees that change, it pulls it down, it applies it, and it makes it look that way. So you can use a workflow in GitLab to move it across your environment so that everything is mirrored and everything matches up all the way. And you know exactly what's going to happen when it gets there instead of having a surprise in production. Now, how many people have perfectly up-to-date documentation that exactly matches the state of the infrastructure on the last deployment? Right? There's no hands. What's cool about infrastructure as code in this context is it's basically executable documentation, right? It is a written down state of where everything is. And if you do this right, and this is the sole source of truth for your environment, it always matches because it has to. So the goal here is to drive it to a point where logging into a server interactively and making a manual change is a security incident because you've gotten away from your change control now. Next slide. So typically the sort of like, originally when it was coined, the term was DevOps, and we had DevSecOps, and later on was, you see the problem illustrated with a wall of confusion, right? So there's a graphic where there's someone chucking a package over a wall, and there's a big brick wall in the middle, and there's someone on the other side who's going to receive that package and doesn't know it's coming. And those two groups aren't working together. So, you know, if you've been a developer, a lot of times the production environment feels like a black box. You don't know what's running there. You don't know how it works. You write the code, works great on your machine, right? We've heard that before. Well, the operations team, they get something, they get a tarball, or they get a jar file, or there's some other type of package, and they receive it, and they're expected to make it work, and they didn't have any feedback in the building of it, right? And a lot of times, this development process had run for a really long time. So this starts to make operations resistant to change. But ultimately, you know, the mission needs change to win, right? Because our adversaries are improving, and they're getting better, and if we're not, we're falling behind. So, you know, how do you reconcile this? It's with the quality play, right? Because when you improve the quality, all your deployments are smoother, operations can become less resistant. But to get the quality up, people have to work together. And you know, if you went back 10 years ago and said, you know, would we have devs and operations working together? Could we even have this conversation in DoD? It seemed really ugly, right? Because you had the natural inclination towards sort of the tribalism of the devs and the operations team, but you also have this notion of separation of duties. And it became sort of virtuous to pit the different silos against each other. So, you know, dev against ops, dev and ops against security, and everyone's working against each other trying to get the work done. But really, like, what we need, everyone needs to care about the mission outcome, right? Because no one wants to deliver insecure software. No one wants to deliver broken software and systems. We want to give the warfighter what they need. And if everyone gets behind that, then that starts working. And this is where working cross-functionally, you know, in an agile way starts to make a lot of difference. It's also where, you know, working together in those feedback loops, you know, dev is talking to operations back and forth. And, you know, sometimes the best DevOps tool is a shared meal or a drink or something like that to encourage the convergence of people and processes. Sometimes you can do more. Don't get me wrong. We think you need Jira and Confluence and GitLab and all the rest. But like the thing that might get it going is breaking that. To break it free might be that simple. As far as the complexity, we hear a lot. People ask us, how do we get started? You know, how do we get the ball moving? And, you know, just do something small, right? Make a process consistent and automate it. Have lunch with your security person, have lunch with the developer, have lunch with the operations person. Start talking back and forth. You know, I worked in an environment where, you know, they weren't quite ready for infrastructure as code. And we made some changes, like we set up an IIS server, right? And every time we set up an IIS server, everybody will go out and Google the setting to remotely manage that every single time. So we thought, well, why don't we just start writing like we're making the change in PowerShell. Why don't we write one-line PowerShell stuff and just start adding that up? Well, I mean, it's executable documentation then, right? It's the same thing. All the steps are outlined and they're right there. Now, that's not full-on infrastructure code. That doesn't achieve these goals. But it's easy and it's iterative and it's a good step in that direction. And it doesn't have to be that, but just do something small and something simple that solves a small problem in a small way. You know, because ultimately, again, like the way we're going to defeat our adversary in this context is to outlearn them. And ultimately, that's what all these systems and all of this feedback and all of this testing for stuff and finding defects, it's all about learning and improving faster. And I think that's all we have. Is there another slide? Well, to close it out, we received our ATO. We are onboarding beta customers now. We're working on our final DWICF approval. That will happen soon. After that, we'll be able to increase the rate of adoption for everybody. And feel free to scan the code if you want to get in touch with us. Are there any questions?
How do you determine what new functionality and tools should be part of the tool set?
All right, so I had a feeling that question was coming, given the audience, and I appreciate it. So the answer is we're going to look at our customers, right? We're going to feel customer demand signal, but we need help from the vendors too. So tee it up for us, right? So make it easy for us. You know what we're offering here. You know kind of like the price point we're going after, right? So help us, understand your business case better. Who else? All right.
How are you managing your software supply chain risk with this?
So how are we managing it, or how do our customers do it? So I'll answer both. As part of GitLab Ultimate, there is some SBOM capabilities, and then for us, we're using things like DoD Cloud IC, which has been vetted by DoD and Air Force Platform One. Now, like I said, GitLab Ultimate is not the only tool out there. I'm not saying it's the best tool, but it's the one that we have for SBOM at this point.
We are using containers built by Iron Bank that are hardened and built by the vendors. They have a lot of tooling and documentation that goes along with that. That's one of the reasons we were able to move so quickly. We did write a bunch of our own automation to kind of connect DoD IAC up to the point where we could deploy Big Bang, but we really benefit a lot from all the work they did and all the work of the people that are participating in that community, both of which GitLab and Atlassian are doing. That's easy. Normally we get a lot more questions than that. Yeah.